Alrighty, hi guys. This is going to be a super simple and very short lesson. I just want to touch on some of the basic properties. It's really straightforward though. You will be like, what? That's so easy. And I'll be like, I know. So here we go. All right. So this is technically in section 12.1, which talks about like your introduction to your limits. And this is properties of limits. First thing is like just some basic limits. What this is saying is that if you've got um, b and just b is just some number, then if x is approaching some other number, this would just be like, that whatever that number is. It's like an example of that first property or that first basic limit would be something like if I had the limit of like say 5 as maybe x approaches something like say 1. Well, according to the graph, that would just be a horizontal line at y equals 5. And as I'm letting x approach a value of 1 from both the left and the right-hand sides, the y value is always up here at a y value of 5. So that limit would just be equal to 5. And that's what this first property says, that whatever the value is here, the limit's always just going to be that number if the limit is just a number. In the second scenario here, if you've got a linear function, like your parent function, y equals x, and we're taking the limit on that one, so something like the limit of x, as say x approaches some number c, so we can let that be whatever we want. We'll say x equals 1. Well, that would just be your parent function, y equals x, which would look something kind of like this. So if you want to approach the x value of 1 from both sides, so let x approach 1 from both the left and the right-hand side, y will be approaching whatever the value is at that spot, which is also 1. So that property just says whatever, if we've got the parent function, just y equals x, then the limit will always be equal to whatever c is. So in this case, that would just be 1. And then the third basic limit just says that the limit as x approaches c of x to some power n. So maybe we'll have x approaching 1 again of say x to some number like, I don't know, x to like say the 5th power. Well, they're just saying over here that whatever that value is, you can just take it to be that power. So this would just be 1 to the 5th power, which is 1. Really, these basic limits are just talking about, you finding a limit with a substitution. That's always your first approach. So nothing fancy there. All right, then the properties of limits. And these will go into your content library. So if you don't get these copied down, they're in your textbook, but they'll also be in your content library. I literally did a Google search and just screenshotted a picture and posted it in here. So, all right. So what the properties say, it's again, very, very simple and very straightforward. But what the first property says, I'll give an example of that one. If I've got something like the limit of say 2 different functions being added together, so maybe I have like the parent function x squared and I don't know 5, and I want to let x approach say 2. What this property says is that you can basically take the limit of each one of them separately and then just add their limits together. So this is the same thing as me saying the limit of x squared as x approaches 2, added to the limit of 5 as x approaches 2. And back up at those basic functions, or the basic limits up here a minute ago. If the third one, just x to some power, that would just be c to that power. So in this case, this would just be 2 to the 2nd power. The second one here is the first basic one, approaching just a number. The limit would always just be that number. So that would be 5, which tells me that this would be equal to 9, would be my answer. But really, again, all I just did was I substituted technically that 2 in for x. So I really didn't do anything crazy. But I'm using that first one. The second property says that if you've got some coefficient, like in this case k, being multiplied by some function, you can put that coefficient in front of your limit if you want, and then just take the limit of that thing. So that example would be something like, if I had the limit of, say, 5x as x approaches, say, 3, well, using that property, I could take that coefficient of 5 here, and I could move it in front of my limit. So that means I could have 5 times the limit of x as x approaches 3. And then now this is that one of those basic functions where if I just plug it in to that linear piece, I would just have the limit on that would just be 3, which means my limit would be 15. But again, all I really did was I had to plug the 3 in right here in the very beginning, which is what you were already doing. So I'm not trying to add anything extra on for you. I'm just trying to show you how these properties work so that way you can understand and use them. Okay, third property says that if you've got two different functions being multiplied together, you can take the limit of each individual one and multiply them together. Okay, so that would look something like, I have the limit of, let's say, 5x. We'll just use that exact same one as x approaches 3. Well, to show the third property there, I would just take the limit of 5 as x approaches 3 and multiply it by the limit of x as x approaches 3. And now these are two basic limits again. So the first one is a basic limit, which is would give me 5. And the second one is a basic limit, which would just give me 3, which gives me the same limit of 15. Again, I'm just showing you how the properties get used. This is more helpful later on in calculus. The fourth property is showing through division. If I've got like some function divided by another function, I could do the limit of the top one divided by the limit of the bottom one, and that would be the same thing. So an example of that might be something like the limit of, I don't know, x plus 2 over x minus 3, and we'll say the limit as x approaches 2. So what that property says is that we would do the limit of the x plus the 2 as x approaches 2, and I would divide that by the limit of the x minus 3 as x approaches 2. And then if you really wanted, you could use that first property where we are splitting up through addition or subtraction. So then I could technically break this up as the limit of x as x approaches 2 added to the limit of 2 as x approaches 2. And then do the limit of x on the bottom as x approaches 2. Oh, this one's got to be subtraction because it's subtraction between them. And then minus the limit of 3 as x approaches 2. And now they're all basic limits. So the limit of x would just be 2, the limit of 2 would just be 2, the limit of x is 2, and the limit of 3 is 3, leaving me with 4 divided by -1, which is -4. And again, what we were doing last week was we were just substituting, which would have also worked. But, you know, again, I'm just showing you the properties that were introduced in this, technically in this section that I just hadn't talked about yet. Okay, the last one says that if you've got the limit of some function to a power, then you can take the limit of the function and then raise it to the power. So last example of that last property would be something like the limit of, I don't know, say 2x cubed as x approaches, say, 1. That property would tell me that I could do the limit of the 2x first as x approaches 1, and then raise the whole thing to the third power. And again, if you wanted to use the multiplication property where you could split up through multiplication, you could do the limit of 2 and then multiply that by the limit of x. And then all of that is to the third power. I would not normally do all of these. Like this is, you know, a lot more work. It's just, I'm showing you these properties. So now we've got 2 basic limits. The first basic limit is just the number. Second basic limit would be x, and that would be 2 times 1 to the third power, which would be 2 to the third power, which would be 8. And again, I would have just much faster just substituted like we were already doing. But those are the properties from that section, and that's all there is to that. Pretty easy breezy.